affect any one of us in this room. And I hope all of you have been listening to that very carefully. What Riza is going through right now is not something anybody wants to enjoy, and that's why we're very serious about getting this project done. Current research is still very rudimentary in this area of nano research. They're just trying to move it to like a size of memory stick that we have. And this would be a complete device which can control it internally. However, it's not in the market yet, so there is no good news for all the insulin people. This is another approach that a Switzerland company is trying to do. Now this, again, allows you to deliver 100 mils. 100 mils over a period of about, this kind of dimensions, they are achievable. Now Riza has told you that he needs one of these in a year. So if this implant can go and we can solve the efficacy aspects and half-life aspects, reducing the amount that from this to maybe a smaller amount, and with that, if it can go in the body, with a proper control valve. Now, insulin high or insulin low, they did not mention it's a very serious condition. Either one can kill you. So one can damage your internal organs, and the other one can really put you to sleep without pain. That's what Riza described to me. It's a good way to commit suicide.
Yes.
I'm serious about it.
It's not allowed. I have to speak.
It's true. I mean, it may be gaudy, but it's true for all medical people. Now, the other aspect of solving this problem is to actually create live cells, which can be captured in this. If you want to recognize this a bit, it's like the stent that they put in your arteries that allows you to prevent you from having heart attacks. Now the similar stent is now being developed where internally you put live cells. And the good thing about this is it's like a stent solution. It lasts very long. And here you do not have to replenish any insulin. The cells produce it, and through this nanotechnology it can diffuse out. Only the cells remain inside. Now, the good thing about this is, if you have realized, some of the insulin, the cells in the pancreas are attacked by their own body. That's why you keep losing them. With this nanotechnology, those cells that go around attacking them will not be able to reach the cells that are producing insulin. So it's like insulin can flow out, but the cells that are attacking it cannot flow in. So this, I think it's very promising. One of the experiments in California, they're trying to put that whole implant in the pancreas itself. You might see a video on that if you all are interested. If not, we can move on faster. Now, the other thing that Riza explained to you was his go through all those injections to test his glucose level alone. Now, even there, the technology hasn't been so advanced yet. This is the most promising one that allows them to detect at nano levels the equivalent of glucose in your blood through saliva. Now that solves 300 million, Riza? So many millions of people's problem on this earth where they don't have to have those injections. You saw the baby that Samia showed you, and that can be very torturous. Every day you have to go through some tests to check what is your glucose level. Riza is a living example of that. And if this can come to life, through saliva you can detect your glucose. That solves half the headache of insulin for 300 million people around the world. Now, this technology still is in infant stage, but this is a patent that was submitted in 2010 by a team in Munich. What they are doing is, there are two mechanisms. One is pH, and the other one is an electrode. Now, whenever there's an electrode, unfortunately, it means there's invasion into your body, and those parts can get infected. So the electrode part is not a good solution, but by changes in pH, they have found that you can open up the pores and the valves. It's proven, so it's patented already, and people can develop the other aspects of delivering this. There's some promise that it will work. Now, how nano valves work? It's very much like the team presented earlier about this antigen and another antigen. Now, if you have the right molecules, they open up, and then this goes out. When the molecules are not there, this closes again. In very layman terms, that's how nanovalves work in the body. As Riza has explained, these molecules can be glucose, can be anything that you want, depending on the antigen and the substrate that you put on the base, and then you can decide what it can attract, at what level it opens up. All this is controllable at the nano level. This is another technology that's being tried through the skin. Again, it's diffusion. It's not really like injections. Not proven yet, so it's still on a non-live person. This is already available. Notice that 400 units, it lasts a week. If in Riza's term of the unit I use, this lasts a week, and this is available already. But this again, if you, I think this is the Riza, the needle.
Yes, yes.
It means you get poked. But now for a week instead of, and the main problem with this is infection. So they have not been able to solve it, although this company, prides that they are one of the best in the world. I don't know if Riza bought this, but you can detect it on the phone after that, on what is he getting in and out, because it's a sensor as well in there. Monitors his. No. So, Riza, shall we show the video or no?
Yeah.
Go ahead. Oh, as usual, face this problem.
And I'm using nanotechnology to develop an artificial pancreas.
You mentioned the pancreas one just now. California.
Imagine putting one capsule into the body and having it take care of diabetes for you. No more pinpricks, no more insulin injections, and it sits there for as long as that patient needs it. The pancreas does many things, but one of the most important functions is to regulate the levels of sugar in your body, and it does this by secreting insulin. What we do is we take the cells of the pancreas, the ones that secrete insulin, and we put them in this tiny capsule, which is nanoporous. So what that means is that they have little holes that are extremely small, and those holes allow for the insulin that is released by the cells to come out into the body, but they're small enough to keep out all of the things that might attack those cells. So this square device is actually a capsule, and it has a central reservoir where you can put millions of cells, and the back of the reservoir are the tiny nanopores. This is a prototype capsule, and it's actually 10 times larger than what would be implanted in a human. But each of these little rectangles is actually millions of nanopores. We like to think about the capsule as almost like a tea bag. So with a tea bag, you put a bag of tea in some hot water, and the hot water flows into the tea bag and releases the tea molecules that are sort of sitting inside that netting. The same thing can be said with our capsule, but instead we have sugar that comes into the capsule, and it alerts those cells that we've put inside to secrete insulin. We make these capsules in a clean room because nanotechnology creates devices that are smaller than dust. And so if we actually created in a normal lab, we would have dust coming down on our device and actually potentially clogging up the pores. The real benefit of nanotechnology is creating that small pore that can only allow for insulin to go out, but doesn't allow for these large immune cells or antibodies to come in. You can't actually do that with anything that's on the large scale.
Okay, with that, I'd like to conclude the presentation. We are planning to open up this company here, Samia, Riza, Lin, and Singh Technologies. We're looking for venture capitalists, and we are in the research and design stage. It's pretty urgent because of our colleague. We're looking for 1 million grant from the Canadian government. Patent might come up soon, depending on our alignment sequence issue can be resolved. And all applications can be sent to Samia if you want to join this venture group. Thank you very much.